Okay, so question 12, again, we're finding a derivative. The best thing to do with question 12 is to rewrite it. So anytime I have an expression in the bottom of a fraction, I can rewrite it with its power by making the power negative. And then that just makes it easier to find the derivative of, because I won't have to do a quotient rule. I can just simply do a power rule. So now, when I go to do the derivative, the power is going to come to the front. So there's my -5. I'm going to leave the parentheses alone, subtract 1 off the power, so that makes that a -6. And then I go back with chain rule, and I multiply by the derivative of what's inside. So the derivative of 2x is just 2. And then go ahead and simplify. -5 times 2 gives me this -10. And then I have my 2x plus 1 to the -6. And I don't even care whether you leave it written like this or you write it like that. I think my math lab took it either way, but keep in mind, even if it doesn't, I'm grading your work, so I will take it either way. Number 13 is another chain rule. Remember that the derivative of e to some power is just e to some power. So that is a basic derivative. If you have an e to a power, that derivative is e to the power. And then, of course, you've got to worry about if the power has a derivative. So when I look at this, I already have a 5 in front. And so the derivative of my e to the 2x is just simply e to the 2x. But then, because of chain rule, I have to go in and say I'm going to multiply by the derivative of the power, which is where the 2 comes from. So my final answer there, when I multiply the 5 times the 2, I get the 10, and then I have my e to the 2x. It's probably one of the easiest derivatives, other than, say, the derivative of a constant, which is always 0. So same thing on 14, chain rule involved again. So when I'm looking at this, the derivative of e to some power is just e to that power. But then I go back, chain rule says I then multiply by the derivative of this power. So the derivative of x to the 4th is 4x to the 3rd. And I don't care if you left your answer in this order, it's okay. They're going to write it. They're going to always pull a constant to the front and write it like that, but either way would be acceptable. And again, I'm going to be comparing what's on paper to your answer, so I'll catch it if you've typed something in my math lab for some reason, counted it wrong, and it should not have been. Now, 15 is one of those problems where if you don't remember your properties of logarithms from the first part of this course, and you try to do the derivative based on how you derive a logarithm and a product, it gets really ugly. But if you remember that the log of a product is just the sum of the logs of the factors, you want to do that first, and it makes it so much easier. So this is a product here, and I'm breaking apart this product by taking the log of the first expression, and then I'm adding the log of the second expression. Now, the reason that makes it easier is because the derivative of a logarithm, of a natural logarithm, when you have a natural logarithm of some term, is always just 1 over that term, and then, of course, times the derivative of that term. So when I have the log of 2x plus 3, I'm going to take the 2x plus 3 and put it in the bottom of the fraction here, and then go back and take the derivative of the 2x, which just gives me the 2 on top. Same thing on the second one. The log of 4x squared plus 3, when I derive it, that 4x squared plus 3 just goes in the bottom of my fraction. And then I go back and just simply take the derivative of the 4x squared, which gives me the 8x on top. And they don't require you to get common denominators. You're just stopping right there. So that's definitely remember that particular property of logarithms. Okay, on 16, you have no choice. You've got to do a product rule. So remember, with product rule, we'll take the derivative of the first term, which is the 5x to the 4th, multiply it by the second term as is. So that's where I'm getting my e to the negative 9x. And then we say plus, and then we derive the second term. So remember, the derivative of e to a power is just e to the power times the derivative of the power. So that's where the negative 9 comes from, and then I multiply by the first term. And so, again, if you leave the answer like that and you don't put it in a factored form, I'm fine with it. If you look at their answer, they go ahead and factor, since both of the terms have this e to the negative 9x, they go ahead and factor it out. I would think they would also factor out the x to the 4th, but they didn't. So as long as your answer is the equivalent, whether you factor it or not, I'm fine with it. Finally, on 17, this is where we talked about continuity. So it's just asking you, where is the function? Where is it discontinuous? Well, that's where you're looking for holes in the graph. So you'll notice the first place is right here, where you've got a hole and then it jumps up. So that would be the value negative 3. And then the other place we have a hole is when x is equal to 0.